Hi, I'm Tanish, and in this video we're going to do ellipses, conic sections part 2. In the description I've linked what conic sections are. If you haven't watched that video, then I would suggest that you do so. An ellipse is the set of all points x, y such that the sum of its distance from two distinct fixed points called the foci is constant. If I have a point, its distance from the two fixed points will always be constants. If I call this distance 1 and distance 2, then distance 1 plus distance 2 will always be constant. If there's another point and it's on the ellipse, then the sum between this and this will be the same distance as distance 1 plus distance 2. There are two types of ellipses. There's the vertical ellipse and there's a horizontal ellipse. And these are the equations for them. We have x minus h whole squared is divided by a squared plus y minus k whole squared is divided by b squared is equal to 1. And here it's x minus h whole squared divided by b squared plus y minus k whole squared divided by a squared, which is equal to 1. Now let me explain what a and b are. So the distance from the center, this is the center, to the vertex. The vertex is the point furthest from the center. As you can see, this is this distance over here is the biggest distance. So if you this distance over here would be called A, and the distance from the center to the point on the ellipse that's closest, this distance will be called B. So that's our A and B. And the foci, the distance from the center to the foci will be called C. This is the C distance. Now you can find the C distance if you have the A and B distance. So C squared is equal to A squared minus B squared. Always remember, that's something that you have to remember. And there's also something called E. Now E is equal to C over A. This is the same C over here and this is the same A. So E determines how oval, basically the ovalness of your ellipse. If it's either so stretched out or it's enclosed. As E gets closer and closer to 0, then it gets closer and closer to a circle's. So its ovalness gets closer and closer to a circle's ovalness. If it's 0, then if E is 0, then it's a circle. You can automatically assume it's a circle. As E gets closer and closer to 1, the ellipse gets more elongated, gets more stretched out. If E becomes 1, then this will no longer be an ellipse, it'll be a parabola. You know what a parabola is in the previous video. I have that also linked in the description, so check that out as well. Now, there are two different axes over here. All right, there's the major axis and there's the minor axis. The major axis is the largest distance from one point on the ellipse to another point on the ellipse. These points are called the vertices, basically the vertex. One vertex here and one vertex here. But the minor axis is the smallest distance between 2 points, and that we call the covertex over here and the covertex. So these are the covertices over here. So the major axis is equal to 2a, and that should make sense because it's 2 a's of a distance, right? Because the center to the first vertex is a, and the center to the second vertex is also a. So a plus a is equal to 2a. The same should apply. So the distance for the minor axis should also be b. So this center to the covertex, and yeah, so it'll be 2b. So remember when I was first mentioning the definition of an ellipse? I had a point on the ellipse, right? And its distance. If I added distance from the focus, if I added them, d1 plus d2, it's a constant number, right? And that constant number just happens to be the major axis. So if I were to, wait, this was 2b, sorry, this distance of the minor axis is 2b. I accidentally put 2a. So yeah, as I was saying, the distance for this d1 plus d2 distance is a constant number, right? Well, that is equal to the major axis. And the major axis, as I said before, is equal to 2a. So this is distance 1 plus distance 2 is equal to 2a. Just remember this, because your math teacher might create a quote-unquote fun problem out of this. I've had my math teacher do this a bunch of times. It got annoying. Yeah, it's a little underused for me, but that's what makes it the perfect trick question to ask. Anyway, moving forward, it's what happened here also happens here. The only difference between these ellipses is that the major axis over here is horizontal, but over here it's vertical. So let's label the things again. Okay, so this distance here is A. This distance here is B. I'm not drawing these quite well, but there we go. And this distance would be C. These equations aren't really different. Also, the equations are the same on the top, right? It's x minus b wholes, x minus h whole squared, and y minus k whole squared. This here x. The only difference is in the bottom, where it's a squared and b squared. That difference is because over here we call this a because this distance a is on the major axis, and since it's horizontal, it has to be under the horizontal x value, right? But over here, since the major axis is on the y, on the it's vertical, it's underneath the vertical y variable. So that's the only reason it switched out. If you want to think about this equation differently, you can always think that this is x and y are common variable. It's subtracted by the centers x and y, and this here would just be the distance from this x variable to its closest vertex. So this thing to its horizontal vertex, right? So the co-vertex or co-vertex which are on this level, so on horizontally, and if that makes sense. And then this thing underneath here would be the distance over here from horizontally from the center to the point on the ellipse horizontal. So that's if that kind of makes any sense, right? Yeah. So the vertices can be determined by h plus a comma k and h minus a comma k, and that makes sense because if our center is h comma k, right? If you take it a distance to the right, you get a vertex. If you take it a distance to the left, you get a vertex. So there's a translation happening here, and for covertices, it's h comma k plus b and h comma k minus b. So if you take the center, go up b, you get a covertex. If you go down b, you get another covertex. The foci is since it's c distance from the center, the same applies here. C to the right and then C to the left. And over here, it's not quite different. To get the vertex, so the vertex, it'll be h comma k plus a. So going a distance up to get the vertex, and the h comma k minus a, which would be one a distance below. And the same applies here and here. You don't need me to explain all that. But quick note, the foci is always going to be on the major axis. So over here, the foci is on the horizontal because this is the major axis here. When you're trying to find the foci, you got to be careful. If this is a horizontal ellipse, you got to add c to the x variable, right? Or subtract. You got to add or subtract c to the x variable here. But if it's vertical, then the foci would be on on the major axis, which is vertical as well. and you gotta add or subtract c from the y variable. Graph x minus 2 whole squared over 4 plus y plus 1 squared over 9 is equal to 1. Identify foci, length of the major and minor axis. The generic equation for an ellipse is x minus h whole squared up h whole squared is over a squared plus y minus k whole squared is over b squared is equal to 1. What we do have to do now is figure out what a and b are. So, and we have to also figure out the center. The center we can figure out pretty much quickly. We have x minus 2 whole squared and y plus 1. So since it's minus 2 and it's minus h here, the h would be 2 and the k will be it'll be minus negative 1 here, so that'll be comma negative 1. This is our center, so if we find that here, it'll be 2 comma negative 1. So center. We want to find our a and b here. We want to take the c. What we have to do now is find the vertices and the co-vertices so that we can connect the entire thing and create our ellipse. And after that, we could find our foci. The foci is not necessary to create the ellipse, but since the question asks, we gotta add it. So let's do that. Now uh, a is always going to be our largest length, all right? And over here, this 9 over here would be is greater than the 4. So our a is in fact not underneath the x, but it's underneath the y. So let's get rid of that and put the a over here and b over here. Now since a squared is equal to that 9, right, then a would be equal to 3. Because we can't have negative distances, we will disregard the negative 3. And then b squared is equal to 4. That means b is equal to 2. Again, we disregarded the negative. So we go up 3, 1, 2, 3. We get this. This is our first vertex, called vertex 1. And we go down 3, 1, 2, 3. And this will be vertex 2. And then we go left and right 2. We go 1, 2. So this is co-vertex 1. We just call this co-vertex. And then go left 2, which will get us co-vertex 2. Now we just connect them. Just imagine this is an ellipse. Ellipses are hard to draw by hand. Imagine you're just looking at this right now, right? This is it. I'm not really good at drawing. Let's find the length of the major and minor axes. So the major axis is equal to 2a, and 2a is equal to 2 times c, which is 6, and the length of the minor axis is equal to 2 times b, which is equal to 2 times 2, which is 4. So this is our major and minor axis distances. And now we gotta identify the foci. To find the foci, we first have to find c. And c squared is equal to a squared minus b squared. This is something you have to remember and keep it in your mind forever. So a squared we know is 9 minus b squared is equal to 4. So c is equal to root 5. Alright. And the foci, since the major axis is vertical, we have to translate up and down from the center. So let's do that. So we go from 2 comma negative 1, we go up root 5 to get 2 comma root 5 minus 1, and we also go down root 5, which we'll get 2 comma negative 1 minus root 5. These will be our foci. Even though they didn't ask for it, let's just quickly find the vertices and the co-vertices. So it's similar to how we found the foci. We have the center, and since let's start with finding the vertices. So we go up and down. We go up and down 3 in the for the y. Right? We change the y. We go up plus 3 and we go minus 3. So the vertex 1 will be 2 comma negative 1 plus 3, which is equal to 2, and then vertex 2 is equal to 2 comma negative 1 minus 3, which is equal to negative 4. Then co-vertices is instead of the y variable, we change the x variable. Now we go up and down 2 instead. We go left to right 2, right? So we go 2 plus 2, which is 4 comma negative 1, and co-vertices 2, this we go left 2, so that will be 0 comma negative 1, and we solve this.